Welcome, everyone. I'm Garrett Weinzerl, and I'm sitting here today with Dr. Sarada Kuravi. Thank you so much for joining me today.
Oh, thank you for inviting me.
I appreciate it. I'm very much a layman in this field, and I understand that you have an invention called Amped TES.
hmm Well, it's the short form for Amplified Thermal Energy Storage.
Okay, so talk a little bit about that. What is amplified TES?
TES is Thermal Energy Storage. It's basically a heat storage system where we store heat from any source. Let's say it could be from data centers, or it could be from power plants, it could be from any electronics, like let's say from the car engine, anything like that. So we store the heat temporarily and we use it, reuse it, or dissipate it depending on the application. For example, in the car, maybe we can reuse some of that heat, or we can just let it go so that the engine cools. So uh, thermal energy storage, it stands for, it's basically a heat storage device. So amplified is because we have an invention where we are amplifying its storage capacity compared to other techniques.
So how did you get into the field of thermal energy storage?
When I did my PhD, it was in something called a phase change material that is typically used for thermal energy storage. So I was using that to cool electronics basically. Where I found that the problem with thermal energy storage materials, basically the phase change materials, would be their low conductivity or low heat transfer capability. And after that, when I was doing my postdoc at the Clean Energy Research Center, it's also basically I was working on power plant thermal energy storage systems and also something hydrogen storage systems, wherein also I found that heat transfer is a very big problem. And also the basically current techniques that are being used are something that will definitely enhance the heat transfer but also add extra weight to the system. So I thought about how to overcome the disadvantages, some of the disadvantages associated with current techniques, and I came up with this idea.
Oh, wonderful. So how does the final product work?
Well, it's basically very simple. You add some particles to the storage material, whatever we want to store the heat in, a very few particles, and then we vibrate them using an external magnetic field. So these particles, while they vibrate or move around in the system, they transfer the heat faster compared to if we don't have any of those particles or the movement at all. So uh, so that's very simple technique, and this technique can be used anywhere or any place, or it can also be changed. The shape of it can be changed. Let's say you're looking at a cylindrical system, or if you're planning to remove heat from uh, a small, let's say, engine, or battery cooling for a car, then you will have a rectangular shaped battery, let's say. So we will have the rectangular shaped container. That's all. So it's basically simple. We just wind the alternating magnetic field coil around the system, the storage material, and we place it there. So any shape, any size, basically any size, once we optimize it, we can use it.
So there seems like there could be many different applications for this material. So I can assume that narrowing down your ideal customer is probably kind of difficult because there's a lot of different industries that this could be applied to.
Yes, actually, let's say depending on the temperature, basically I'm looking at, let's say if we're looking at car engine, we don't want it to cool above certain, I mean, heat above certain temperature, right? Usually we try to put it near the ambient temperature. Let's say 20 degrees C or 30 degrees C. So we use a material that changes its phase, or that can store heat at that temperature. That's it. Or if you're looking at a power plant, and if you're planning to recover waste heat from a turbine or so, then we use a different high temperature material. So it's just the storage material that's already there. It's electromagnetic field technique that's already there. So it's just joining these two techniques, and we get a faster heat transfer.
Wonderful. So you talked the automobile industry. You talked about power generation. Well, are there other applications as well?
Yes, yes. Let's say data centers, cooling of data centers, the defense electronics, in space, thermal management in space, in dairy, milk pasteurization, and so on. Uh, well, yeah, like that. So there are a lot of applications. Wherever we use thermal energy storage, we can definitely use this technology.
Fantastic. How long was your how long did your research take for this product?
Well, one thing is, I think I got this idea before I joined NMSU. It's just around less than 2 years ago. And once I got this idea, we just did some experiments in the lab. And I tested different materials and different heating sources. Let's say where the heat is coming from. It could come from the bottom of the container, side of the container. It could be stored internally or anything like that. So it took me around a year to get good results for both different types of materials. But the initially when I got the results, I directly approached the Arrowhead Center. So I should say in less than 2 years.
Wow. So you hit the ground running once you arrived at NMSU.
Yeah. So when I joined NMSU, I think within that same semester I approached Arrowhead Center regarding this.
Is AMP-TES patented now?
Yes, it's already the full application has been submitted already, and recently. So,
Well, congratulations. What was that process like for you? Was this the first time you've ever had? Sorry.
Yeah, Arrowhead Center, they really helped me. First thing is I went to them. I told them about the idea, and they said, okay, we'll help you with initial presentation with IPAC. So they helped me with finding more applications, if I can find more applications, and they helped me with the presentation process. So that was pretty easy for me. And once it is done, they said that yours is approved, so we are applying your professional. So it was just submitted that, and after a year, they said, okay, we need to apply again, do another presentation to show where your product is. And it was also very fairly easy, and we applied for the full patent. And meanwhile, actually, Arrowhead Center was helping me find more or advertise my technology. So they actually helped me. They actually selected my invention for a technology showcase that was in Albuquerque, and few companies actually approached me that they are interested in this technology as well.
Wow, that's wonderful.
Yeah.
Well, congratulations. It sounds like it's been a very successful for you.
Yeah. Thank you.
Are there any other applications past this? Now that you have your product, what's next?
I think that once we start applying this to each and every application, let's say if we are designing it for a battery or if we are designing it for a power plant, I would think that each and every one of those designs would be a new invention, because right now we are saying the basic technology is this, but yes, once we are applying this to it and we are optimizing it, I'm pretty sure it will be different one. So it is definitely opening a new areas or new paths for us.
Well, before we wrap this up, any closing thoughts?
Well, I would like to say that this definitely has a lot of applications, and I believe that we, I believe that definitely this product will help improve the thermal energy storage systems. Actually, its cost is 40 to 60% lower compared to current techniques. I forgot to mention that.
Oh,
But
wow. Yeah, that's
advantages of this technology, right? So can I explain for a bit?
Absolutely. Yes.
Yeah. So this technology, right now, what people do is they use foams, fins. These are just the extra materials they add to the system. And if you compare, just say a small volume of a system, now we are removing a storage material and adding these extra materials to improve the heat transfer. So in this technology, in the current invention, we don't add those extra materials that are will add weight to the system, occupy a larger volume. We add a very small amount of those particles, and then we wrap the system with the electromagnetic coil. So now the system weight is considerably reduced, and it's very much cheaper compared to the technologies. Our initial calculation showed that for the same system weight, we could actually store around 10% extra energy, and the cost could be 40 to 60% lower compared to the current techniques.
So it's more efficient and it's less expensive. So it is just a win-win.
Yes, yes. And another, as I said, that it could also be changed to any shape and any application. And there is another advantage too, that for these techniques, they definitely have to have a certain conductivity. For example, if we use foams type of materials, they have a certain conductivity. We cannot change that. But for, in our case, if we change the voltage of the magnetic field, we can change the conductivity or the heat transfer, how much heat is being transferred. So it's almost like tunable, and we are amplifying the heat storage. That's why it's amplified thermal energy storage
Right.
system.
So yeah, it gives you a factor that you can alter and that you can play with.
Yes, yes.
That's fascinating. So was that the breakthrough, or was that the idea you had from day one before you even ended up at NMSU?
Um, well, I didn't, until I do these calculations, I didn't know how effective this was or how much cost effective this was. So once I did those, then yes, after I came to NMSU, I did some of these tests. So I would say after coming to NMSU.
Well, that is fantastic. So,
Yeah.
well, thank you for your time. I appreciate you coming by and sharing your research and informing us about your product.
Oh, thank you for your time too.
Have a good one.